So, good day students. Now, the main aims of this nugget are to give you a realistic idea of how much biomass is available and what are the limits. The reason I want to show you this is that I have been teaching bioenergy since the late 1970s. And I've seen that most people, when bioenergy is mentioned, tend to think that bioenergy is the same thing as the cultivation of energy crops on agricultural land. But it is not. And I want to make sure from the very beginning that you do not suffer from that misconception. As you saw from the lecture part of this nugget, is one limitation to the production of biomass the photosynthesis process. Under very idealized conditions, we found that the production rate could be at the very most approximately 8 kilos of dry and ash-free substance per meter square and year. This is for the virgin, growing, fresh biomass. Let's now take another global view. Just like with the photosynthesis, we will make it very simple and do the estimate in our heads. You might remember from school that the circumference of the Earth is about 40,000 kilometers. And then it is simple to estimate the radius of our planet to about 6,500 kilometers. The area of a sphere is 4 times pi times the radius squared, and for simplicity we set 4 times pi at 12. 6,500 squared is equal to 6.5 squared multiplied by 1 million. 6.5 squared is a bit difficult to compute in your head, but it is obvious that it must be bigger than 36 and less than 49. So one may just assume 42 as a rough estimate. Then the total area of the world becomes 12 multiplied with 42 million square kilometers. So the total area of the world becomes about 500 million square kilometers. But then about 70% of the area is oceans and only 30% is land. Let's now assume 7.5 billion people. What we then find is that the land area per person is approximately 20,000 square meters. And assuming a football field at some 70 by 100 meters, then this is just about 3 football fields. But then there are different types of land around the world. Approximately 0.85 football fields is infertile. That's deserts and ice and high mountains and such. Approximately 0.85 football fields is forested. Approximately 0.85 football fields is covered with poor grass, so this is the Central Asia and the savannas in Africa and so on. 2 times 0.15 football fields carries rich grass, which is good enough for grazing cows and cattle. And 0.15 football fields is fertile agricultural land where we can grow fiber for clothes and food for eating without artificial irrigation. You would not want to spend that small piece of land for energy crops. Seeing the world like this, you will realize that biomass for energy can only be taken as residues from agriculture, from forestry, and from society. And you will realize that growing biomass is a limited resource and that we must economize with it. So what you shall do now is quite some extensive reading so as to really understand the limitations. First, download and read both papers about the photosynthesis process. It is important that you understand roughly how the process works so that you have in the back of your head the fact that there is a fundamental limitation to how much biomass can be produced. Second, you should read chapter 0200 in the Busy Plan Handbook. In this chapter, there are a number of tables to give you an idea of the specific biomass production in tons per hectare and year of several different types of biomass. Third, you shall read all 5 chapters in column 1 of the Busy Plan Handbook. I've got a cat coming in here, and that's what you hear in the background. You do not have to read them all in detail, but scan through all the 5 chapters so that you have an idea of which resources are at hand as biomass is concerned. Once you've done this reading, then just start thinking about which resources might be available in your own home region. How much virgin biomass? How much from agricultural activities? What about the city's wastewater treatment? Is that used for energy? And, well, whatever. So open your eyes and mind to the possible resources.